Okay, all right, so we're talking about polynomials. 20 minutes of your time, and then we'll be good to go. So what are polynomials? This is the new unit that we're starting today. You guys took a test earlier this week. I'll get it graded for you and get it back to you, but today we're starting a new unit. Polynomials. Here's what a polynomial is in the simplest term. Polynomial, does that word make sense? Polynomial. Here's what a polynomial is. A polynomial, let's just call it this. It's a collection of terms. A collection of terms. So that could look like a couple different things. Like this, 2x squared plus 3x plus 4. That's a polynomial. Each one of these things is a term. Each one of the pieces, we call that a term. Okay? That's a polynomial. This is also a polynomial. It's just one thing. How many terms does it have? One. This is also a polynomial. That's a line. We dealt with those a lot. How many terms does that have? 2. Does this make a little bit of sense? So a polynomial is just a collection of pieces, numbers and variables, and it could have a certain number of terms. So I kind of talked about this already. A polynomial with 2 terms. We'll zoom in here a little bit so you can see it. A polynomial that has 2 terms. There's a fancy word for it. We call it a binomial. Polynomial with 2 terms is a binomial. Like a bicycle has 2 tires, right? A binomial has 2 pieces. What do you think a 3-term polynomial is going to be called? A trinomial. Oh my gosh, you're a genius. A trinomial. Just like a tricycle has 3 wheels. Does this make a little bit of sense? So you got binomials, you got trinomials. Those are really only the only 2 fancy words we're going to deal with. So, a polynomial is a collection of pieces. A binomial has 2 terms. Trinomial has 3 terms. It could have a million terms, but we're going to focus on those ones in particular. Let me give you the different pieces of a polynomial. So this thing up here is just an example. 2x cubed plus x squared minus 5x plus 12. That's a polynomial. How many terms does it have? It has 4. It's got 4 pieces. All right, so we just call it a polynomial. There's some different parts to it. This one right here is called the leading coefficient. That's fancy math language for first number, or the number in front. Okay? That is a leading coefficient. Another thing that a polynomial can have is a degree. That's fancy math. Well, I'll tell you that later. So here's the leading coefficient. It's 2. Here's the degree. It's 3, and I'll tell you what all that means in a second. And then we have one more piece. It's the last thing. It's called a constant term. And that is the piece at the very end. And if you're trying to write this all down, you can write it down if you want to, but remember, it's going to get posted on Google Classroom. I'm writing fast? I'm going for... Okay, good. How long have I been going? 4.5 minutes. Woo! What does that mean? 3 or 4, that's when I started, 20 minutes. I'm going based off of that thing. It says 4 minutes and 45 seconds. Okay, leading coefficient. I said that's the fancy word for first number. So the first number that you see is the leading coefficient. First number. So what's the leading coefficient of this thing? 2. And it's the first number. It's the number in front. The degree. The degree is the highest exponent that you see on the polynomial. So now we're talking about the powers, right? We're talking about the little numbers. So what's the highest exponent in that polynomial? 3. It might be kind of hard to see. It's a 3 right here. It's a 3 in this case, but it might be something else for another one. It's not always 3. And then the constant term is something with no variable attached to it. So that's 12 in this case. It's called constant because it doesn't ever change. And it doesn't ever change because there's no variable attached to it. So those are the main pieces. You got a leading coefficient, that's the first number. You got a degree, that's the highest power. And you got a constant term with no variable. Just make a little bit of sense? Okay. All right. Another thing that we need to talk about. Standard form of a polynomial is the way that we will usually write a polynomial. So I'm just going to tell you what it is. A polynomial is written in standard form when the powers, so we're talking about exponents, when the powers of the terms decrease from left to right, okay? So this one is in standard form. This one is not. Can you tell me why? Well, there's numbers attached to the exponents in both of them. Were you saying something, Sam? Did you raise your hand for a second? What were you saying, Peyton? X to the power of 2 first, B. That is the problem. Why is that the problem? Because there's no number in front of it? That's not the problem. The problem is here. It goes 2, 3. This goes 3, 2. So this is what this means. The powers need to decrease from left to right. So they need to be biggest to smallest, going from the left to the right. Does that make sense? I'm talking about the exponents, not the numbers in front. So the powers, the exponents need to be they need to be ordered largest to smallest from left to right. And once they are, we're in standard form. Does this thing have an exponent, just a single x? Yeah, what is it? No, what is it? Look at it. What is it? What's its exponent? What's the power? 1. That's what I wanted to hear. It's a power of 1. If it's just a single x, single variable, it has a power of 1. All right, so that's standard form. Let me give you an example of that. So it says write each polynomial in standard form, then identify the degree and leading coefficient. So let's just focus on this one, number 1. Is that in standard form right now? No, it's not. Are the exponents ordered largest to smallest? No. What would you need to change? Switch these ones? That won't fix it either. Flip this one? Well, I think this one needs to be in front for sure. Which one would come next? X. It's minus x, right? And then plus 4 at the end. Now it's in standard form because the exponents are largest to smallest. You have 2. Remember, this is a 1, and then you have none. Does this make sense? All right, what is the leading coefficient of this thing? 5, just 5, the number that you see in front. First number, that's the leading coefficient. What's the degree? What is it? How do you know it's 2? It's the biggest exponent that you see. Binomial or trinomial? How do you know it's a trinomial? Because there's 3 pieces. Wow. Unbelievable. Is this in standard form? Think about it. Yes, it is. It's missing a second one, but that's fine. It goes 3, 1, 0. So it's biggest to smallest, right? What is the leading coefficient? So just the number. What's the number? It's just 1, but it's not just 1. It's -1. What's the degree? The degree is 3, and it's a trinomial. So remember, if there's just a single x, there's no number in front of it, there's technically a 1 in front of that. And since it's negative, the leading coefficient is -1. Is this making a little bit of sense? So to be in standard form, you got to order it biggest to smallest. Leading coefficient is the first number. Degree is the biggest power. Okay? What do I got? 9 minutes? 8.5 minutes? I like this system. You don't? You have 8.5 minutes. 8.5 minutes, and then we're shutting it down. All right, in that 8.5 minutes, this is what I got to show you. We are going to do things with polynomials. We're going to add them, we're going to subtract them, and we're going to multiply them. You're not going to divide them. That comes in algebra 2. But you're going to add, subtract, and multiply them. Today, we're just going to think about adding them. So if I tell you how to add, if I tell you to add this and this, here's how you do it. It's pretty straightforward. First off, you want to pay attention to what you're being told to do. Well, you're being told to add. So we're adding stuff. We're not subtracting stuff. And then we just want to do like terms with like terms. So you do like x's with x's, x cubes with x cubes, numbers with numbers. All right. So first I got 2x cubed. I have 2x cubed here, plus, is there an x cubed over here? Whoa, 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 that's x squared though. I want to do x cubed with x cubed, so it's just one of them, right? So if I have 2x cubes plus one more x cubed, how many x cubes do I have? 3. Unbelievable. And then I just keep going. I move on to x squareds. I have negative 5x squared plus, is there an x squared in the other one? It's 2. Okay, so I have negative 5x squared plus 2x squared. What's that? Negative 3x squared. Okay, now I just keep going. I have x. Is there a single x over here? Nope. Don't let it freak you out. There isn't. There's no single x. That's okay. What? Oh, I thought you were talking to me. It's x plus nothing. There are no other x's. So it's just x. Okay, and I still need to deal with this. Is there, remember, we call this a constant, right? Because it has no variable. Is there a constant in this one? No, but there is a constant in this one. So here's how you can think of it. It's like 0 here, nothing, plus -1. What is that? -1. So now that I've done each one of my terms, I just take these things that I have, all my new pieces, and I write them together in standard form. So what color do I want to do this in? Let's just do it in black. It's going to be 3x cubed minus 3x squared, since this is a negative, right? Minus 3x squared plus x minus 1. And we're done. Is that in standard form? Yes, it is, because I go 3, 2, 1, nothing. So I'm in the right order. Does this make sense? Okay, what do I got? 5.5 minutes. Oh, wait a minute. I think there's another one I wanted to do. Never mind. Let's just do a couple more examples and then we'll pack it in, okay? Let's do this first one. So same thing. I'm adding. So I'm going to be adding stuff. I want to do like terms with like terms. You can't do x and x cubed together. That's not the same thing. All right? So I have 3x squared plus 1x squared. What's that? 4x squared. I have, what's next? 1 single x plus 4x. So what's that? And then I have -6 plus 10, which is +4. So what's my final thing going to look like? 4x squared plus 5x plus 4. Wow, you guys are good. Unbelievable. Let's try another one. Let's do a hard one. Let's do this one. We're going to do number 3. I got 6x plus 2x. What's that? 8x. So I just keep going down the line. Where's the x squared over here? It's right here. That's negative. So it's x squared plus -3x squared. That's the same thing as x squared minus. It'd be -2x squared. So 2x cubed plus 5x cubed. What's that? 7x cubed. So have I done all my pieces? Did I do all my pieces? I did all the pieces, right? So we're good. So what does it look like in standard form? Seven x cubed what? Well, these are my pieces. I got to order those pieces in standard form. So that's -2x squared plus 8x. How come you ordered them like this? You mean 3 is the biggest exponent. So we go 3, 2, 1, and we're done. I hope that didn't show up on the video. All right. Do you feel okay about this? Does this make a little bit of sense? Yes? This part? So I have to order it with the exponents going from biggest to smallest from the pieces that I ended up with here. Okay? Does that make a little bit of sense? So you guys see how I set this up? You just do one piece at a time, find its matching piece, add them together. That's your new piece. Once you get all your new pieces, you have to order those in standard form, and then you're done. You might get to the point where you can do this in your head. So like if you tried to do this one in your head, I got 30 seconds. 3x squared plus 5x squared, that's 8x squared. 4x plus 2x is plus 6x, and 3 plus 1 is plus 4. Is this in standard form? Oh my gosh. Unbelievable. Okay. And